As is always the case, I'm going to give you a lot more homework than what you really need to do. If you completely understand a concept, that's all you need. I will say that as you look at, say, problems 5 through 22, the problems may look different, but once you can make the connection, see the similarities between them all, and then move on to the next section. I mean, look at some that may look more difficult and then go from there. Now, on each of these, it's asking you to find the limit. The limit of x to the fourth as x approaches 2. The first rule whenever you do limits is see if you can just put the 2 or put the approaching value into the function. So, can we? Well, does 2 to the fourth exist? Absolutely. So just plug 2 in. 2 to the fourth is 16, I believe. Same thing on number 6. Can you plug it in? Yeah. Negative 2 cubed is a negative 8. Each one of these, as you go down, you can plug in. Now, you'll see each line is a little bit different. You can plug in 0 here and get negative 1. You can plug in negative 3 here and get negative 7. We come down here. These are all 5 through 12 are continuous functions everywhere, so you can plug in whatever value you want. 13, we have an issue, potentially. There is a value we can't plug in for x, and that's 0. But we can plug in every other value. So x of 2, just plug it in, you get a half. 14, same thing. 2 over negative 3 plus 2, well, that's a negative 1. So 2 over negative 1 is negative 2. You're done. Each one of these, I think you're going to find from 15 to 20, it's the same story. Okay, and when you get down to 21, it doesn't matter. These are continuous functions. The issue we'll have on 19 and 20 is positive square roots. You make sure it's greater than or equal to 0. So plug that in, we get a positive 4, good to go. Cube roots, continuous everywhere. You can plug whatever you want in. The key point with all this is whatever you can plug in, plug it in.